Hello and welcome to m253. My name is Lapuz, instructor for the course, and we are looking at this checkpoint 5.41, where we have a Q region bounded by this plane and the coordinate planes, and we're looking at a density function, and they want us to find a center of mass. So in the previous checkpoint, we found the mass itself. We found the boundaries that would make up the solid Q, and we used those boundaries to be our limits of integration for our triple integral, where we put in the density function. So in order to find the center of mass is going to be a collection of averages, so to speak, x bar, y bar, and z bar. So that's the center of mass. That's to find out, given this density for this particular solid, where the quote balancing point is for this three-dimensional object. So in order to find x bar, what we need to do is come up with the moment around y and z, and then we're going to divide by m. So what is this moment that they're talking about? So the m, y, and z is going to be this triple integral over q. So it looks like this mass formula as triple integral of q, and then you have this density function, but we also want to include an x times that. So generally that's how you would find the average for a probability density function, and so it works the same way for finding the moments for the average. And then we have, of course, m, which is going to be given by this value. All right. So essentially, for us, we need to do this triple integral kind of like 3 times and then divide it out. So the triple integral from 0 to the 1/3 6 minus x minus 2y, 0 to 6 minus 2y, and then 0 to 3. Of not just the density function, but x times the density function. So it's going to be x times y, or x times parentheses x times y squared times z. Of course, you can multiply that out if you want. This is in the order of dz, dx, dy, just copied directly from the mass. Okay, so we need to figure this out. And then we also need to figure out the y bar. Well, let's see if we can come up with that. We're just going to punch it into the calculator and get a result. And by doing so, we're going to get this result for this first one. This is the integral of x times y squared times z, and this is dz going from 0 to that plane, dx going from 0 to 6 minus 2y, and then dy going from 0 to 3, and then I got 81 over 35. All right. So similarly for the y bar, we're going to need m, and this is going to be xz or zx, and then mxz is equal to the triple integral of the same thing, except we'll have a y multiplied by the density function x y squared z dv. Okay. All right. I actually found that also, and I'll just put the results here after punching it into Wolfram alpha. And then finally for the z, we're going to need mxy over m, where m xy is equal to the triple integral over the same region. This time we multiply the density function by z, and then we integrate. So that will result in this sum right here. All right. So now that we have that, we're gonna, oops, this is z bar. So now that we have that, we're just gonna put everything together. So I actually typed up the work needed already. So I'll just place the results here. Knowing that our mass is equal to, what is 54 over 35, we'll take the first moment that we saw and divide it by 54 over 35, and we get 3 halves for that. And for y bar, it's this 243 over 140 divided by 54 over 35. You get 9/8. And then the last one, we take 27 over 35. That was our moment around the z. And then we divide it by the mass, and we get 1/2. So our final results would be that the center of mass is equal to this 3-dimensional point. So if we take that point, 3 halves, 9/8, and 1/2, somewhere within this, you'll have your center of mass. Okay. All right. I hope that helps. Good luck.